Hello, everyone. Welcome, welcome. It is my pleasure to introduce our next speaker today. Next up, we have AMIN TORA, and he is the Cybersecurity Analyst at ARAMCO. And today, his talk is entitled Adversary Threat Detection Using Artificial Intelligence and Machine Learning. Okay, AMIN, you can join us here on our virtual stage. You can share your video. Great. Hello. And I'm just going to turn my camera off and you can share your slides and you're ready to go.
All right. Hello, everyone. My name is AMIN TORA. I'm a cybersecurity analyst with Saudi Aramco. And I'm here to talk to you about some cool stuff, I hope. It's adversary threat detection using machine learning and artificial intelligence. Quick disclaimer before we start. So any comments, opinions, views that I express here are my own and not that of my employer. Okay, with that said, I wanted to cover real quickly machine learning and artificial intelligence in terms of the scope of things. What is AI? What is ML? You kind of hear about this almost everywhere you go. People ask, what's the difference between AI and ML? And I'm sure the audience here are pretty acquainted with it, but still, maybe some of you may not have, it might be new to you. So in general, artificial intelligence is the overall encompassing domain or area of research and operational implementation. And artificial intelligence's main objective is usually to be successful. Within that, you have machine learning, and within machine learning, you have representational learning, and within that, you have deep learning. Now, as far as machine learning, its objective is mostly towards accuracy and precision. So we create models, and the models' objective or success would be in terms of how accurate is it, its precision, its recall. So if we look at it from a point of view of like, for example, a self-driving car, the objective of the self-driving car would be to get from point A to B without having any collisions, accidents, obeying the law, and being able to change lanes and these kind of things. The overall objective. But what it's using is it could be using machine learning. And there's all kinds of autonomous vehicles. We're not fully there yet, but we're working towards that. And it needs to observe its surroundings using radar, using video imaging. And for that, it needs to figure out how to steer, observe its surroundings, navigation, and it needs to use representational learning as the data is coming in, and it's analyzing some of the data sets. So for that, it needs to recognize important features, identify patterns, either perform some data compression or reduction or noise reduction. So that's in the representational learning areas. And then within deep learning, we have neural networks that actually recognize objects and other problems as well, but be able to solve other problems. Be able to detect traffic lights, people, cyclists. So that's the general idea there to get you started. Now, within cybersecurity and machine learning, you could define it as solutions that utilize mathematical models using established algorithms, or maybe if you're clever enough, you come up with your own new algorithms to detect and identify threats and anomalies. And as a general case where you may have a neural network, you can take some values like a domain like good.com and convert it to ASCII and feed it into a neural network. And within the neural network, you have some functions and weights that get changed as you're training it. In this example, like a binary classifier. And you can have bad and you train it good and bad, and it figures out between good and bad. It's labeled data, supervised learning. So overall, within cybersecurity, we're trying to find the either anomalies with unsupervised learning, or classified from known bad sets. We can classify and identify new bad that's going on in our network. Now, the question might be, why do we need machine learning in cybersecurity? The general approach has always been from the known knowledge set that we have as human beings. In the known case, cybersecurity stack or traditional stacks, they utilize signatures, right? We have a lot of IOCs everywhere. We can utilize heuristics, similar matching, and dynamic analysis. There's a lot of sandboxing going on. There's a lot of static analysis that's performed. And these are all known knowns. Even dynamic analysis, after you analyze it dynamically, it's still looking at correlating against known knowns. And within that, you may also have some not aware of some things, but you may not you may not have some understanding of things, but you might be aware of some bad that's going on. So you could possibly do something with that intelligence. So some of the known unknowns you could utilize. But in general, the unknown space will be much larger. So it's basically the whole universe of unknown, and we can't ever accomplish knowing everything there is to know. But that's where the general set of the bad that can happen. The good news is that both blue teams and the adversaries, or even your red teams and purple teams, but versus the adversaries out there, we're in the same boat. So our knowledge set is still limited, and we're both trying to tap in to the unknowns, which is a dynamic environment, of course, and trying to mitigate against the adversary. So in a normal cyber security operations approach, you have your known knowns. So you have you can have a competent cybersecurity team with really good understanding, which is their skill sets, their knowledge base. They may have very good awareness, CTIs, cyber threat intelligence, and operationally it might be interconnected well, and the security stack might be integrated, automated, but still it's traditional. It's still relying on the known knowns. And what's important is that the unknowns, where the adversaries will utilize from the unknown space to perform their attacks, their threats, tactics, procedures, and everything that they do, and new ways that they come up with. What happens is that you need to use machine learning and AI, for artificial intelligence, machine learning, for the for being able to identify the adversaries. And of course, there's different approaches: classification, regression, clustering, statistical analysis. And what happens is that cybersecurity teams, however, aren't fully there yet. In some organizations, you'll have really good, competent, but a lot of other organizations and small to medium businesses, you may not have the full capabilities. So in those cases, you need to increase your understanding and increase knowledge base capabilities. You need to improve operationally. At the same time, you need to have more awareness as far as the threat intelligence, and increase situational awareness, improve capabilities, and operationally intertwine with that. Now, what do we need to go from the traditional mode to cybersecurity based machine learning capabilities? For that, in general, you would need two things. One is a focused cybersecurity AI and machine learning team that they understand AI, they understand machine learning, they understand cybersecurity. And this is where the team would develop use cases that are relevant to your gaps of what the organization needs, and try to cover the unknown unknowns. And that's where you analyze and look at, okay, what data sets do you need, what features, and you start developing models using AI ML. And of course, you also need a machine learning platform. So for the platform, it can be near real-time platform. It could be storage-based, which is a Lambda platform, or a Kappa platform, which is an all memory-based. Now, the idea is that, in the unknown space, we're trying to identify either anomalies, as I've put here as an example. And once you've discovered the anomaly, you have some awareness of it. And once we have the awareness, we can analyze it, look at it. And if it is malicious activity, then we know that we've detected it, and we can work towards mitigation. So, and after that case, it becomes a known, where we have some understanding of it, awareness of it. So that's the general approach. Now, once you have this, you also need a focused machine learning or AI based threat hunting team. And for that, you need a lot of automation, because a lot of the output from the machine learning models, they need to be correlated, assessed, analyzed. So you need to automate with SOAR IRP solutions. You need to have an integrated security stack, and the team themselves, they need to understand that the models that are developed and what they're detecting, they're approaching things from a statistical point of view and probability and statistics point of view. So they'll need to understand that the outputs doesn't necessarily mean it most likely is malicious. It's just more of a mathematically founded assessment of whether this activity is anomalous or not. It deviates or it closely matches something that's known to be malicious. Now, the ML team also needs to have a good situational awareness in terms of cyber threat intelligence, and they need to have great capabilities as well for in-depth analysis. So we need to go deep dives into forensics, memory analysis, reversing, and network-based analysis. Now, there are commercial solutions out there. So as far as commercial solutions, it doesn't mean that they don't always work for you. You can spend a lot of money and buy commercial solutions, but you may find that they may only cover you partially. Some of the reasons may be they may have limited scope or visibility to the context of your network, of your environment. And the approach that the commercial solutions may take may be too broad to be truly effective. In some cases, models that you develop in machine learning, sometimes you'll need to modify the structure of the model itself. You might need to change the way features are extracted depending on your environment. And also, the statistical distribution of your data set will always vary versus another organization. And usually commercial solutions, they'll try to approach it more in a general stance. Otherwise, they'd have to end up handling a lot of models and a lot of different differences across different customers. And a lot of solutions come with a closed approach, where the models, you can't really get some insight into the model itself. They won't let you look at the way it's developed or the way structure or the source code. And what happens is, you go deploy these commercial solutions, your team's not ready, and at the same time, your team's not operationally ready for ML, a machine learning based approach. And what happens is the commercial vendor also may not have a full understanding of the gaps in your environment of what you're looking to do, because maybe we ourselves may not be aware of our gaps. And the traditional team is not ready. So and down in the unknowns, in this diagram, if you look, there are areas of the unknowns where an adversary may be utilizing to attack you. This is dynamic and changing, so it's not always constant, it's not always changing. So it's difficult to difficult to have a silver bullet solution in a sense. All right. How can we get there? In terms of moving towards having a strong team with cyber AI ML, you need to make sure that within the known space that you're able to improve your cybersecurity team in terms of understanding, awareness, capabilities, integration of the security stack, automation. It's got to be there, or you should move towards working on that. As far as the awareness, CTI, cyber threat intelligence, situational awareness of your environment, understanding of your environment. So all of that has to be in place. And then once you have this, then you can start looking towards knowing your gaps, knowing the limitations of the security stack, what are the areas that can be bypassed. So this is where you'd use a red team, purple team type and external as well, red teams, to kind of find the holes and gaps in your environment and places where you may not be aware or have some weaknesses. And the whole idea is to focus on threats and actual threats. And what happens is, as much as the unknown space is very difficult to get a grasp on, adversaries still have the same patterns and behaviors that we do, because we're, a blue team does, because we're human beings. And there's only so much entropy we can introduce into our actions, whether it's our knowledge, whether it's our capabilities. So from that aspect, you can study adversaries. So you can look at their TTPs, you can look at historically what they've done. MITRE has the attack framework, and you can look those up. SANS has a lot of material around that. SANS even has, for one example, is like a C2 matrix that they've built that you can download and look at all the different command and control channels. And you'll find that a lot of the adversaries are either lazy, or they just keep using the same material, same code, same tactics, procedures. And from that aspect, that gives us the ability to start creating in what's called in the statistical theory information space is that you can start building predicates around what they do, and based on that you can start looking at creating use cases. Once you know your gaps as well, you can start creating those use cases and focus towards phishing, browsing, DNS channels, credentials, lateral movement. And look at these areas and VPN connectivity, site-to-site networks, and look at hidden channels, and you can even use AIML within false positive filtering. So these are the areas, and as you do this, you have to keep in mind also that we have to look at the actual threats. So don't always be misled, but also don't forget or neglect some of the areas. So we need to look at, what does the adversary have in terms of capability, opportunity, intent, and look at the actual threats and try to focus on that first before you start covering some of the other bases and areas. All right. So real quick closing thoughts. In general, I think a lot of organizations have tried or are trying to utilize AI, machine learning, and they may have had some success. A lot of organizations may not have found a lot of value, and those are some of the areas that my talk I tried to cover, where you have to have your team ready, and the operational teams that you have to understand the difference between an alert coming from a traditional stack versus an alert or an anomaly that you detect coming from an AI ML approach, looking in the unknown space. So for that, you need to make sure you have the traditional team ready, and you need to put together. I think to be effective, organizations should establish cyber, AI ML teams that with more of a DevOps approach, where you review and continuously develop use cases and focus on the actual threats from adversaries. and strategize, collect information, data sets, features towards models, work through the full model development process, and cover the full life cycle within AI ML. Additionally, you need an ML platform. It doesn't always have to be a large data lake in that sense. So at least to get started, you would need the data somewhere and feed it into your models. So you can just do some kind of streaming batch, and you don't always have to store it. And a lot of organizations have access to the cloud, so you can leverage that as well. And in order to operationalize cyber AI ML, you need to have a focused threat hunting team, and that focuses specifically on cyber AI and ML anomalies. For the most part, the statistical approach, probability and statistics. You need to have everything in order in terms of your traditional security stack, automation, and continuously, improve situational awareness and knowledge capabilities, because both domains, that's where they cross over, and that's where you can be more effective against adversaries. All right, and that's it. Thank you.
Okay, great. Thank you so much, Amin. That was great. You can unshare your screen and camera, please. And if everyone could give Amin a warm virtual round of applause. I hope you all enjoyed it, and stick around for your next session. Have a great time.